We're going to start section 14.4 today, and the first thing we're going to take a look at is surface area. So surface area refers to the number of square units that are needed to cover a three-dimensional surface of an object. So imagine you're trying to wrap it up like put wrapping paper on a box. That's what surface area is. It's the part that's on the outside of the object. There's two kinds of areas involved when we talk about surface area. There's lateral surface area, and then there's what I would call the base surface area. So lateral means around the edges of an object. So imagine if you had a can of soup. We're going to do an example with the can of soup next time. The lateral would be the around the object of soup, the paper that they wrap around it, okay? And then the bases are the top and the bottom. And they're usually a different kind of an object, more often than not. Okay, so lateral area is the space around. The surface area would be the sum of both of these kinds of bases. So you can see on this one, the lateral faces on all of this particular object are rectangles, right? But then the bases on the top and the bottom are a different object. They're pentagons. All right, so if we had a cube, for example, this one actually has the feature where all the faces are exactly the same, right? Because it's a cube, and a cube has a feature that says that every piece of its faces is a square. So this bottom part, we've seen nets before. This would be a net for the cube. If I were to fold it along those edges and wrap it up, it would turn into a shape of a cube. What would we get if we were to do the surface area of a cube? Any ideas? All right, so one of the areas of the cube is s squared, right? One of the faces area is s squared. One of them or all of them? It's actually all of them on this object, isn't it? All of the faces have an area of s squared. So now how many faces are there? 6. There are 6. So the area formula for a cube, for surface area, is 6s squared. Okay, we'll do one more to give some sort of a sense of how this works in general. This is that same image you saw on the first slide where it's a pentagon on the top and the bottom, and I talked about it being rectangles all the way around. So if you take a look at the net along the edge over here, you can see it all broken down and sort of spread out. How many rectangles are there? 5. Why are there 5 rectangles? Because the pentagon has 5 edges, so there's 5 rectangles. All the rectangles have the same height, correct? And they have the same width, correct? So you could talk about the width being the perimeter of your object. Or you could talk about being the sides, 5 sides added together. So when you're looking at this shape right here, the lateral area, that is the area of those rectangles, is the perimeter times the height. Okay, so jot that down, perimeter times height. And it's the perimeter of the base. And then we have our bases. We'll say base area. Well, the base area is whatever the base area is times 2, because there's 2 bases. So the general formula for the surface area of a prism is that we have 2 bases. We have one on top and one on bottom. This is the area of a base. And we add to that the perimeter of the base times the height of the prism. So this P is the perimeter of the base, and the H is the height of the prism. Okay, is everybody with me on that? All right, we'll pick back up and add more to this next